Differential equations. A differential equation relates some unknown differential function and its derivative. So obviously we're looking at the word derivative in regards to this. So we're just going to have a quick discussion on whether what the definition or what that definition relates to, and how we apply it in regards to examples. So these are our three examples. We're just going to state if they are differential equations. The definition that it's got to have a derivative means that part A and B are differential equations as they have derivatives represented, whether it's first or second derivative, even third derivative. And part C is not, as it doesn't involve a derivative at any point. So when we talk about the order and degree of a differential equation, the order is the highest order that the derivative has, and the degree is a bit like our polynomials. So it's the highest power of the highest order derivative. So we're going to state the order and degree of the following differential equations for those examples. So the first two are the same. I've just replaced the third one with one that's actually a differential equation. So part A is a first order derivative because it's got a y dash, with a first degree because that's y dash is only to the power of 1. Part B is a second order derivative because we have a second derivative. So we've got a y dash and a y double dash there, but we go with the highest. So it's a second order, and that y double dash has only a degree of 1. So it's a first degree. And part C, the highest derivative is y dash, and that y dash has a power of 3, so it's a third degree. Verify a differential equation, whether a solution is available. We check by doing the derivative and substituting into left-hand side and right-hand side and proving that the two sides are equal or not. And this is just using our differential skills from our advanced course and substitution. So we're going to determine if y equals e to the 4x is a solution to y double dash minus 3y dash equals 4y. So the differential of those, e to the 4x is 4e to the 4x, and the second derivative is 16e to the 4x. Left-hand side is y double dash minus 3y dash. So replacing that, you get 16e to the 4x minus 12e to the 4x. That's 4e to the 4x. The right-hand side is 4y, so that's 4e to the 4x, and the left-hand side equals the right-hand side. So therefore, y equals e to the 4x is a solution to that differential equation. Indefinite integrals. So we know how to integrate. This also produces a family of solutions because we end up with a constant. So given y dash equals 3x squared, the integral of that is x cubed plus some constant. And that's a family of x cubes, which could be graphed using various values of c. We can find a specific equation by substituting in the point. So solve the differential equation given that 1, 4 lies on the line. So the integral of that was y equals x cubed plus c. We're going to sub in 1, 4. And we get a c value of 3. So that's a specific one that passes through that point 1, 4. Another definition, first order linear differential. So it has to be written in the form of y dash plus f of xy equals g of x. So that's f of x is one function, g of x can be the same or a different function. You must have a y dash. Note that f of x or g of x could equal to 0. So the following are examples of first order, because the first one is got a y dash. In front of the y, in this case, we've got a minus 3, so that's a function, minus 3's, and the g of x function is 5x. The second one, we've got a y dash in front or attached to the y, the coefficient, if you want to call it, but the function is the sine x, and the g of x is ln x. And for the third one, you've got a y dash, and you've got a function x in front of the y equals to 0. And so the 0 is a function, that's the g of x. The following are not examples. So firstly, the y dash for the first one needs to be by itself, not attached with a y. And the second one, the y cubed must be a function attached to a y. So in this case, it's not, so it's therefore not a first order linear. Now let's have a look at implicit differentiation. So we're going to use the chain rule, which is d dx is d to y times to y dx, along with possibly product rule and quotient rule for this. So let's have a look at some examples. So differentiate the following equations. So the first one we could do, instead of dy dx, we could do dx to y, but we're going to use our new rule. And the second one, we definitely have to use d dx to solve for that. So d dx of x, so we just take the differential of each individual term. So we're going to do d dx of x, d dx of y squared, d dx of y, and d dx of 4. Now the differential of x is possible. D dx of y squared is not possible, so we're going to replace it with d dy times to y dx. The same with d dx of y, and the differential of 4 is 0, so that would just disappear. So replacing d dx of y squared with d dy, so we replace it with the differential with respect to y of y squared times to y dx, and the y, we do the same. We're now going to differentiate each of those terms. So d dx of x is 1, d to y of y squared is 2y times the dy dx, d to y of y is 1 times the dx, and d dx of 4, as I said before, is 0. So now collect like terms. So dy dx is a common factor on the right hand side. So that's 2y plus 1. So if I divide by 2y plus 1, I get dy dx is equal to 1 over 2y plus 1. So that's differentiated. So the same with this one, d dx of each of them. So differentiate each of them individually. Differentiating x, y, that's a product rule. So it's one function times another. D dx of y squared, well, we're going to have to use our chain rule, and d dx of 4 just becomes 0. So once again, so the first one is a product rule. So d dx of x times y, well, that's possible. D dx of y times x, well, d dx of y isn't possible. So we're going to have to use our chain rule, and d dx of y squared, we're going to have to use chain rule as mentioned. So this is the long format where we've got our product rule, and we've changed the chain rule for the d dx of y functions. So d dx of x is 1 times the y, d dy of y is 1 times dy dx times the x, d to y of y squared is 2y times dy dx, and d dx of 4 is 0. So let's just tidy that up. 1 times y is just y. 1 times x is just x, and then you've got your 2y. We're going to take the y over and take out the common factor of dy dx. So dy dx outside of x plus 2y, divide by the x plus 2y, and that's the derivative. Thank you.